Okay, so starting off with this very simple equation where we have 3 times the bracket x minus 2 plus 15 is equal to 21. So first thing we're going to want to do is we're actually going to want to distribute the 3 here into the bracket, making sure that we take care of that. So here the 3 is going to go times x. It's going to turn into 3x. And then we're going to have the 3 times minus 2, and that's going to turn into minus 6. We bring down that plus 15 is then equal to 21. When we get to this stage, we can actually simplify because we do happen to have terms that are similar, such as this constant on this side of the equation and the constant on that side of the equation. So we'll bring those together. So minus 6 plus 15 is 9. So I have 3x plus 9 is equal to 21. In this case, I want to take this number here, and I want to change him sides, bring him over here. By doing that, I'm going to change the positive symbol that's in front of it to a negative. So I'll have 3x. By doing minus 9 on this side, those will cancel out, so 3x is equal to 21, and I have to do minus 9 on this side to make sure it's balanced. And that will equal 12. So now I have 3x is equal to 12. Now I want x all on its own. So here I have a multiplication. What I can do, though, is I can divide this side by 3 to get x on its own, to cancel these ones out, and divide by 3 on the other side. So now I'm left with x is equal to 4. And that is how you solve an equation. To solve an inequality, we'll proceed exactly the same way, except for one tiny difference. So we'll try that difference out. This time we'll put minus 3x. We'll do the exact same one above, but we'll change that coefficient to a minus 3 and see what happens. So in this case we have minus 3 times in the bracket x minus 2, close the bracket, plus 15 is equal to 21. So first thing I'm going to want to do still is I'm going to distribute the 3 into everything but the bracket. So minus 3 times x. Right, that is a multiplication in between there. I should get minus 3x. And I'm going to do the same thing with this minus 2. I'm going to say minus 3 times minus 2 will give me 6. Right, don't forget, when you multiply two negatives together, it actually gives a positive. And then I can bring down this plus 15 is equal to 21. Now I can do the exact same thing I did above. In other words, I can group together like terms. So I can group together my 6 and my 15 because they're constants here. And when I group them together, it's going to give me 6 plus 15, or 21. I bring down that minus 3x equals 21. I want to get rid of this 21, so I'm going to do the opposite. I'm going to bring this 21 plus over on this side. I'm going to subtract minus 21, subtract minus 21. This will cancel out. So I have minus 3x equals 0. If I want the x all on its own, well, this one's kind of obvious. I know what the answer is, but minus 3, x is then equal to 0. Now let's say I want to take this exact same thing, but instead of putting the equal sign, I want to put in something different. I want to put in a larger than sign. So I'm going to just write it right here on the side so we can see the difference. So again, I'd rewrite my formula. Minus 3 times x minus 2 plus 15 is, let's say, greater than 21. So first thing I'm going to do, the exact same thing I did on this side. I'm going to distribute my negative 3 to everything in the bracket. So the first step, I'm going to get minus 3x. And I'm going to do the exact same thing to that minus 2. So minus 3 times minus 2 plus 6. Bring down that plus 15. Don't forget the larger than sign, 21. I'm going to do the exact same thing next step. I'm going to group together like terms. So I have that 6 and that 15 still. When I group them together, it will still be 21. That hasn't changed. I'll bring down the minus 3x plus 21 is larger than 21. So now I want to bring this term here, switch its sides. When it switches sides, I do the opposite. So that's a plus 21. Here I'm going to do a minus 21, so it cancels out. and a minus 21 on this side. So now I have minus 3x is larger than 0. I'm going to do the exact same thing that I did here. I want x all on its own, just to make sure. So what I'm going to do is I'm going to divide by minus 3, and divide by minus 3. And this is where that issue comes in, of that difference between solving equations and solving inequalities. If I divide or multiply by a negative number in an inequality, so that idea there, those are negatives, what happens is the sign here switches. So it's no longer larger than, it becomes less than. So when I do that, these will cancel out, so x becomes less than 0. And I can actually look at this and check it out if I wish, and verify that if I have, let's say, a 1, and I were to put this in this equation, I'd have 1 minus 2, that's minus 1, times minus 3, well 3, right, because the minuses would take care, plus 15 is not larger than 21. However, if I went to minus 1 minus 2, that's minus 3, minus 9, times minus 3 would be 9, plus 15, we definitely have that over 21. So this is why it's very important when we divide by a negative number to switch the symbol. If I want to represent this using a line graph, I would be able to, this is the term I'm looking for. I find my reference number, which is the number that I'm comparing x to, which in this case is 0. So I'm going to place 0 in the middle. Put numbers on either side. So I'm going to circle my reference number. I'd only color it in if there's an equal sign. So this is not an equal sign, so I'm going to leave it blank inside. And the smaller than, x is going less than 0. So